Good morning, everyone. Look forward to discussing at a high level. We'll start out at a higher level and then work our way, as Lisa said, into more detail over the course of the day. In this discussion, we'll be talking about sort of laying out the framework for how we think about distribution planning, and in particular, how grid modernization planning fits into that context. And then the presenters following me today and tomorrow will go into deeper dives on different elements of this. So we'll start at a little bit higher level, although some of this will get a bit technical. Next slide, please. Thank you. So I think as many of you are well aware and are probably thinking about on a day-to-day basis as you consider what is needed in the distribution system in particular, are a range of different needs, both customer needs, how reliability and resilience factor into considerations, distributed resource integration and potential utilization, say as non-wires alternatives, as several states have been starting to pursue. Obviously, safety and operational efficiency have always been a core element as well. So as we think about that, we have these multiple dimensions that need to be considered as part of the planning process. And increasingly what states, and I'm sure yourselves are trying to understand with the increase in distribution investment expenditure, largely due to aging infrastructure replacement, is trying to understand what are the best investments to make that give the highest sort of return, if you will, in terms of customer value, whether that's through savings or reduced impact on bills, or just overall improvement in service quality and the ability to meet certain policy objectives. Next slide, please. So as part of that, we start to unpack this more complex planning process into what we call integrated distribution planning. And what this diagram is trying to illustrate is that there are multiple dimensions with respect to how distribution planning has been evolving, as Joe said, over the last decade. In many ways, where we were originally, and in some cases still the case, has been a focus on largely distribution asset management, and then which is down at the lower part of the box there, the diagram in the middle, and then also really sort of assessing what incremental needs may be needed with respect to, say, load growth in the distribution system. So really those two dimensions, sort of assessing the current distribution system and then starting to look at near and long-term distribution planning based on load growth and asset management, have largely been the focus of distribution planning over the years. What we've seen over the last decade is really a need to better understand the changing nature of loads, that is increasing flexibility, as you'll hear more about today, but also thinking about the implication of customer adoption of distributed resources, first with solar largely, but now solar plus storage, which have pretty significant impacts on the changing nature and use of the distribution system. And so as a result, we've increasingly been expanding that horizon to think about those, and system forecasts and scenarios around distributed resources, which again, you'll hear in greater detail today, play a bigger part than they may have done 10 years ago or so. The other is, as we think more about the implication of distributed resources, there's much more of a link to the overall integrated resource planning and transmission planning. And so the touch point there starts to increase over time in terms of the need to really understand the interrelationship as distributed resources, either as net load or potentially contributing into providing energy in some states, need to be accounted for. And then, of course, growing over the last decade with many of the major hurricanes and other events that have been occurring around the country, resilience analysis is something that's really been increasingly incorporated into this process. And so we'll talk more about that tomorrow morning, but certainly that's a dimension that's also being included. Where we end up in this process is really starting to define a new distribution system, that is a system that needs to incorporate advanced technologies, needs to be able to address all the needs that are identified in a particular state based on clear objectives, And that really informs what this grid modernization and distribution investment roadmap. And we're going to dive deeper into this in the next few slides. Next slide, please. So if we peel the onion back a little further, what I described was really kind of started to describe as multiple threads that lead to an overall distribution plan. In this case, what we're looking at is what are those elements of the planning process that feed into the grid modernization strategy, as well as overall distribution investments. But there are really three fundamental tracks that a utility takes with respect to planning. So one is the distribution asset management analysis. That is, what are the aspects around aging infrastructure replacement, how to think about resilience hardening. Those elements are generally part of the distribution asset management or asset planning dimension. And then you have the near-term distribution planning. So looking at incremental improvements on the system, looking at how technology may be employed, how to think about enhancements to near-term enhancements to reliability and resilience as well. But also how to look at and account for distributed energy resource integration and other changes in the near term for load and what customer changes in their usage or and the like factor in. And that near term tends to be somewhere in the 1 to 3 year time horizon, depending on the utility. The longer term planning can be looking out over a horizon of out to 5 years, in some cases out to 10 years, and rarely, but once in a while, they may go out a little further to maybe 15. But that longer term planning, each of these interact with each other, so they're informing each other. The asset management and the near term distribution planning tend to happen on an annual cycle, which informs the work that gets done in the next year or two, and is very much driven off the existing authorized, budgets and authorized rate cases and the like. The longer-term planning tends to feed into general rate case cycles and also the longer-term capital requirements for a utility. So the nearer-term activities then inform the longer-term planning. Both of these activities of planning really feed into two dimensions of grid modernization planning that we're going to talk a little bit more about in detail. One is an overall strategy. That is, what is it that the utility is thinking based on the needs and public policy in a particular state or jurisdiction as to what is required for the distribution system to be able to support and enable. And then from that general strategy, which we'll talk a little more about, there are very specific implementation plans that will then include specific capital investment or other activities that may be required, both for physical infrastructure enhancements, different kind of advanced switches, say, out on the distribution system, which you'll hear more about this morning, but also things like software systems and communication systems and the like in terms of more advanced technology that is incorporated into the grid. So we'll talk more about both of these processes next. Next slide, please. But before we do, it's important to really sort of step back and really understand where we try to go here. And that is often we have this temptation to start thinking about the specific technologies that may be of interest. So thinking about smart metering or thinking about advanced automation or thinking about a particular software system. But really what's most important is we really take this architectural view, which is, what are we trying to accomplish here? And then how do we systematically break down those elements to really define what is the best approach? So as my friends, Jeff Taft, who I've been a colleague with for quite some time, his father, taught him that before you start thinking about a house, you don't start trying to hang the window first. The first thing you do is pick up a pencil and you start to think systematically about what you need. And in this picture, very much like how we think about the grid, as you look at a house, it's made up of subsystems like the plumbing system and the electrical system and the windows and the doors and the flooring and all these elements. And before you start choosing, windows and doors and what you're going to kind of fixtures you're going to use inside the house, you really need to understand: are you going to build a 3-bedroom, 2-bath house or a 2-bedroom, 1-bath house? What size is it? What are you trying to accomplish with the house? Is it for a family? Is it for a single person? What are you trying to do? And so that's really the approach we take as we think about grid modernization. Is we don't focus first on the technology, although it'd be quite interesting and it's always fun to do. The first thing we do is try to figure out what it is we're trying to accomplish, and then we systematically work our way through to ultimately then selecting technology. Next slide, please. So we have this process that we've laid out, and this is not a rigid process, but we think if you have the opportunity, it is best to start with strategy. That is, starting with the mission and principles of your particular state or jurisdiction, and then identifying what the objectives for your particular location, including more specifically the scope and timing of what you're needing in terms of modernization of the grid. And that's going to be very unique for every place. So, fundamentally, what we try to develop with this process is something that can be adaptable for every location for its unique set of circumstances and needs. So it's really important that you all sort of think about what objectives for your particular location, your state or jurisdiction, and the scope and timing of time. And we'll talk a little bit more about these in terms of what we mean. The second is those objectives really define what capabilities and functionality you need the grid to be able to do. And we'll talk through an example. Then off of that, there are a number of architectural dimensions like, so then how do we think about a communication if there's a need for communication or need for, generically different automation in the field, if there's implication for different software capabilities that are needed, how do we think about architecting that in a way that addresses a number of the issues that, many of us are concerned about, things like obsolescence and making sure that it's, most cost effective and the like, and that it can meet the objectives of what we're trying to accomplish. This usually results in a strategic roadmap, so you can start to think about generically the kinds of investments that would be needed. You can incorporate conceptual estimates. So there are a number of strategic roadmaps that several states have pursued with respect to grid modernization strategies and the like, and we've got a few examples to share with you. Those ideally then help inform very specific implementation plans. So that becomes an overarching view, typically a 10-year outlook for what may be needed. In some cases, it may be 5. But those are very helpful, set very good sort of guideposts for then thinking about specific implementation plans that will again get very detailed, starting with something called use cases, which really define the functional requirements that then help inform a very detailed engineering design, and then a very specific technology selection, often through a competitive procurement for various technologies, say smart meter or the like. And then ultimately that gets incorporated into a deployment plan, which includes a very robust business case. Next slide, please.
Hey, Paul, were you going to do a poll?
Yes, thanks. I couldn't see the slide number on, so yes, thank you. So Carrie, do you, I don't have a question in front of me, I'm sorry.
Yep, we're pulling it up. Sorry. Yep,
thank you.
that's the first one, which is the most. So the the audience should see the question. Which is the most relevant to you? Integrated distribution planning or grid modernization strategy and implementation planning? So please select one. Organizers and panelists don't vote, so they're not able to see this at the moment. We are getting about 75% of people who are voting, so I think we will close the poll and show the results. Okay, we are working through this. Oh, there it is. Okay, great. So here are the poll results. 36% said integrated distribution planning, 12% said grid modernization, and 52% said both. Thanks, Paul.
Yeah, thank you. Thanks, everyone. So sort of building on what we were talking about in terms of really understanding objectives, and in here sort of simplifying into these three buckets from the the Venn diagram. They generally impact three potential capabilities: distribution planning, grid operations, and what we call market operations. But think about market here in terms of non-wires alternatives, as states mostly have been pursuing. There are some states in restructured that are also having distributed resources participate in an ISO market, but largely what we're focused here is if a state is considering non-wires alternatives. And so in that context, what we're showing is that the areas that are with a black dot are those areas that have traditionally been areas of focus and a lot of best practices within the utility industry. The blue dots, or the blue half dots, are those areas that are really new or really are changing the nature of how we think about some things. So there's a lot of new ground here, and that's why these workshops have really been formed to try and help think through the best ways to tackle these new areas as we integrate the planning process. Next slide, please. So we developed this taxonomy, this sort of sequential way of thinking about how to move from the set of principles, mission and principles of a jurisdiction, to defining objectives based on customer needs, public policy, and trends that we see happening, to then inform the capabilities that are required overall of the system, and then some very specific functionality, which then help inform the deployment planning process. The result is that when you get a business case for a specific set of investments by a utility as part of the deployment planning, there ought to be able to be clear traceability back to the set of objectives, even perhaps to principles, but clearly to a set of objectives that a state has or a locale has, and the capabilities and functionality, and that there ought to be able to, a utility ought to be able to tell a story that explains how they arrived at that set of investments and how it links back to these objectives. So there should be clarity and a fair amount of transparency about how that came about, and it helps the process that we found in the dialogue and discussions as to the appropriateness and timing of those kinds of investments. Next slide, please. So within this, we're going to kind of drop down into each of the elements and talk about different parts of the process. So the first is some examples on mission, where, again, we're at a very high level. This comes right out of a particular jurisdiction's, kind of mission statements or a set of principles that in many cases are on your websites or, on printed material in your offices. I won't read these out, but you can see that, we start at a very high level, and we can work off of these to make sure that, as we think about the development of grid modernization plans, that we keep these things in mind and we just sort of work our way down in greater detail. Next slide, please. So in the case of Hawaii and other states that have them as well, but you can see they started with something, similar to what Ohio and Missouri had, and then moved down into a deep, the next level in terms of a set of principles specific to grid modernization. And in many cases, they're, fairly consistent with, I think, what you would find in many, many locations. That is the first two in particular, looking at greater customer engagement and empowerment and choice, maintaining and enhancing safety, security, reliability, and resilience, fair and reasonable costs, and so on. And then you get into, a little bit more specifics about what, sorry about that, what they're looking to accomplish in their particular state. Next slide, please. From this, you can see that we then move into a set of objectives, and what we've done in the DSPx project, this Modern Distribution Grid project, is to identify a generic set of objectives that really on an a la carte basis. So what I'm going to show you over the next couple slides are really an a la carte. It's not saying you have to do all of these. It's saying if you have these kinds of objectives picking from this list, then we would be able to show you through this next set of slides how they relate to certain capabilities, and those capabilities link to functionalities that would be required to achieve that objective, and then from there, a set of technologies that would be linked to enabling that set of functionalities so that you can really see traceability all the way through. So again, these are not, nobody's expecting everybody to do all of these. This is really a la carte based on you choose what makes most sense for your particular location. Next slide, please. So again, what we've done in these maps, and these are in our Modern Distribution Grid report in Volume 1, and what we have are the objectives, so with those same set of objectives I just showed on the prior slide, and then we've, just to illustrate, we've then listed the capabilities, and we have a set of generic capabilities. By the way, these objectives, these capabilities have gone through basically 4 years of vetting with something like 25 states and about 30 utilities. And in many cases so far, we've had something like 20 states, either the state commissions or the utilities use these tools as ways to help communicate how they thought through what was required to meet those overall objectives and what the state was trying to accomplish. So these are mappings. These would show, if you, for example, have an objective on resilience, then you need to think about scalability. That is, how would you address this across a particular distribution system, not necessarily at just one location. Obviously, affordability needs to be thought about in the context of scalability. And in some states, things like DER integration is a scalability consideration. But you can see, where the dots are, you can see the linkages there. On the next slide, thank you, we then take those capabilities and we map them to functionalities. And so we've got a set of functionalities, a fairly long list of functionalities. You can imagine this is like a pyramid where you start out with relatively few objectives, then more that's linked to a broader set of capabilities that then map to a broader set of functionalities that enable it. And there are a lot of cross-cutting elements here, as you can see with the dots. So again, you can take a look at, okay, because of a certain objective that has an implication on capability, then there are a set of functionalities that need to tie to enabling that capability. This seems a little complicated, but in terms of how we think about engineering, and particularly systems engineering and grid architecture, this is an effective way as a utility starts to think through and unpack something that looks fairly simple at an objective level, and how do you translate that into an engineering or ultimately a design? Next slide, please. So let's take a look at two examples. So to kind of simplify this. So if we have an objective about customer choice through information access for small business and residential customers to support decision-making by 2020, which is what we saw with a couple of states over the last few years, there may be a capability to provide online customer access to relevant and timely information. That then drives a function that says I need to have remote meter data collection and verification. I need to have accurate meter data available, and I want to have it available, say, every day for customers. There needs to be a customer data management system to support that. I need or the capability to manage that data, and I also need to have a way to maybe look at energy management, and maybe I want to have some tool to enable customers to think about whether distributed resource, say solar PV, makes sense. in terms of managing their bill costs, or energy efficiency programs and how that might be cost effective for them. And so that functionality is desired to be available for a customer on a utility website. So the technology then ultimately that you may need to support all that includes this range of set of technologies. And so you can see as we move from objective to capability to function, then we can start to map to specific technologies. Next example, please. So here we look at reliability, where we say, okay, we want to improve reliability by reducing customer unplanned outage durations. We want to achieve first quartile KD performance by 2020. In this case, we wanted, what we're thinking we need to do is improve outage identification and customer service restoration. So there are several functions that go with that. One is fault identification, another is fault location, another is fault isolation, and another is service restoration. And there's a set of technologies that link to be able to enable that. And that's the list there. So you can see, again, starting with one objective that then cascades through capabilities and functions to a set of technologies that would be required to meet that objective or help achieve that objective, and certainly support that capability. Next slide, please. So there's a lot, as you can imagine, as we start to look at a whole range of these different capabilities and functions and technologies, it can get quite complicated. So one of the things we do from a strategy standpoint is really try to understand some basic elements, things like what's the structure of the grid, how's it organized, what the topology looks like, how do we need to think about the observability, that is, what sort of sensors do we need to have on the system, how do we think about advanced metering, control and protection, which we'll talk about later this morning, communications to link these things. How do we take the data and manage it so that we can then analyze and provide some information to operators or engineers or customers? Obviously, cyber and physical security are critical components of this as well. These things lay out in particular dimensions so that we can think about a structure inside the utility and how it interfaces with the customer, or particularly in some cases a marketplace, and how these relate to each other, and how do we organize these in a fashion that minimizes the sort of potential for stranded investment and the like. Next slide, please. One of the concepts we have is thinking about the grid as a platform. That is, how do we think about the basic core investments that enable applications to sit on top of and be able to support utility and customer functions, as well as those for other participants. If there's somebody's developing a customer microgrid, for example, how does it interface with the grid? Or if somebody's providing distributed energy resources services back to the utility, how do those things fit? So this idea of a platform that provides this underlying foundation for other applications that come is part of how we've thought about organizing the various investment types. Next slide, please. So one of the things we've done is we've taken a series of sort of generic technology categories, and we've laid them out in a structure here that's maybe called a technology stack that of some of the common grid modernization technology categories, to illustrate the point of which ones we believe are core components. And how we arrived at which ones are core components is we took that mapping of functions and capabilities and then linked to technologies, and we identified those that were essentially the primary support technologies that map to most of the capabilities and functions. That is, these technologies we're identifying here, both in the blue and the green, essentially support all the things that are above the line and what we call applications. That is, you can't have a volt VAR management system if you don't have the elements underneath in the blue and the green. You can't do DER management, say a distributed energy resource management system, without having that effective without having the underlying capabilities shown below. So these are what we call these foundational core components that make up a modern grid. And then the applications are really optional elements that sort of feed into it. Now, often we get this question about why are smart meters as an application? And the reason is that we have sensing and measurement down below, and smart meters and advanced meters can be part of the sensing and measurement, but that's an option. Now, if you are choosing things like a rate that requires, time of use or things like that, then obviously you need to have smart meter to do that, but you need the communications and the data management and some of the other elements that are below there in the foundation for that to be effective. So that question comes up often, and in some cases it may be considered core or not in other places, but fundamentally everything below the line basically are foundations for a modern grid as we look at it. Next slide, please. So one of the things that we suggest to folks to do as they start to think about modernizing the grid is really get a snapshot of where they are at the moment. So where's your starting point before you start thinking about where you go next? And one of the things is we found that people have done is taken that diagram, the prior diagram, and start to overlay in very simple terms, obviously in more detail, say in a spreadsheet, but in a graphical representation, use this diagram to basically illustrate where are they in the progress towards, having, say, technology implementation. I think as you all can appreciate, often, depending on the kind of utility, whether it's crosses over multiple service territories or just even within their own system, sometimes the technology, and particularly in field devices, don't get deployed in one shot and say in 1 year. It may take multiple years to have the deployment happen out in the field. And so this kind of gives you a progress chart as to a very simple, quick view of where a particular utility may be at in terms of their modernization efforts. The boxes that don't show on this versus the prior slide just indicate that they haven't started at all on those pieces, or maybe not. Those pieces aren't necessarily required, but those that they have started are represented here. This came from one utility's example that they used in a filing. Next slide, please. So,
hi, there's a poll.
Yeah.
There's a poll here. It states, using objectives to shape the functionality and therefore investments enables a line of sight to the rationale. This is done either A, proactively with utility strategy development review, or retrospectively by addressing a proposed utility investment plan against the utility's implied strategy based on their assumptions and rationale for the investment. So A is proactively through utility strategy development review by regulator and stakeholders, followed by an implementation plan, or retrospectively by assessing a proposed utility investment plan against the utility's implied strategy based on their assumptions and rationale. We have about less than 50% voted, so we are going to keep it open for another couple seconds. Your option C is either A or B, or neither A or B also are applicable. All right, so we're over 50%, so we're going to close the poll. Thanks. And here are the results. 80%, or almost 80% said proactively, about 5% said retrospectively, and then 16% said A and B. Thank you all.
So you actually can do that either way. Obviously, if you have the ability, starting with the strategy and leading to implementation is what we would suggest. But often commissions will get some form of a grid modernization investment request, and there is an ability to think about recognizing this framework as a way to then ask questions or look for what the underlying assumptions for the utility were in how they developed the plan, and kind of work backwards from what they're presenting to then ask a series of questions about what functionality they're trying to derive, what capabilities, and how does this link to clear objectives around the sort of Venn diagram dimensions, resilience, reliability, safety operations, DER integration, or utilization, and overall customer needs. So through a series of questions, you can back into what the implied strategy was for how they arrived. And if there are gaps, then there are areas to further explore as to whether or not it makes sense to move forward with that investment. In this case, we're switching and going a little deeper now as we think about things like technology. One of the questions that comes up is often is when do we need to think about technology because there's potential obsolescence given the accelerated rate? How do we think about what's the appropriate technology? And this framework is here. Won't spend a lot of time on it, but it's something that certainly we could come back to at some point. But it's one that I found to be useful over the years. It's one I used in past life. And it's really 4 dimensions, but it can get quite detailed. First, obviously, you have to have alignment to the business priorities and policy and customer needs, as we've talked about. So that's number 1. And then, of course, we need to make sure that technology really fits with what we're trying to accomplish, that functionality we talked about. And as part of that goes into, where is the technology in terms of its maturity? Is it commercially available? Is it still in the R&D stage? Is it really at the end of its life cycle? How do we make sure that we're picking technology at the right time and it has the best fit? And obviously, the cost is a consideration. The other thing we tend not to focus so much on is organizational capacity. That is, do we have the capacity to actually implement this technology, or do we need to think about others to help us implement that technology? Because often in a complex grid modernization, you may get into situations where a utility or the like may not have all the organizational capacity. That can also happen with vendors, particularly with startups. That organizational capacity can be an issue, particularly if they're dealing with a very large utility that has fairly robust technology adoption practices. Next slide, please.
Paul, we have just a few minutes left. I want to save a little bit of time for questions. So why don't you go through the rest of your slides quickly, and then we'll go to questions here.
Yeah. So this slide really gets at this technology adoption, and really something to kind of consider is that, what's the timing, and really understanding, where's that maturity, as I said. In volume 2 of our Modern Distribution Grid report, you'll see a whole series of these technology adoption curves, and where currently, based on feedback from industry and talking with technology vendors, where the state of the technology is in terms of its maturity. Several states have found this quite useful in having a dialogue with utilities and others about when the right time to think about adoption is, because it has implications on the overall useful life and the like. Next slide, please. The other thing is, and we'll talk more about this over the course of the next 2 days, but it's important to understand where grid modernization fits in the overall distribution investment. It is not all the investment, it's a part of it. It's an important part, but it builds on things like, fundamental safety and electrical code compliance, aging infrastructure replacement, then things like, distribution design best practices that tie into reliability and resilience, basic distribution automation. And then when we get to the top of this sort of pyramid, that's where all of the, more advanced technology overlays. But it really depends upon all these other foundational elements as we think about this holistically. So as you can imagine, you wouldn't put a lot of fancy stuff on an old sort of system that also needs to be replaced, because you may end up having to replace those things again as well as part of the process. So you really do want to think about this holistically. Next slide, please. We're going to talk more about specific plans, so I won't talk about this. But basically, when you ultimately get into an overall roadmap, particularly as part of a strategy, but even as part of an implementation plan, being able to show how this fits with other investments and the like is an important component. But there'll be more discussion on this particular plan later in the workshop. Next slide, please. And then, again, my colleague Fritz Karl will be talking about this in the workshop, the cost effectiveness framework we developed to try and help think about how you assess the reasonableness of these various investments that make up grid modernization, as it can get quite confusing and complicated as we think about all these various technologies and how they interrelate with each other, and how they're dependent upon one another. So Fritz will unpack this for you over the course of I think it's next day, tomorrow, sorry. I think this is my last slide.
Great, thanks, Paul. I have a couple questions for you before we get into the next presentation. First, actually on this, your last slide here, if we go back one, Carrie and Dominic, I would like to understand better with respect to least cost. So public utility commissions, their charge is reasonable cost, but generally, there is a focus on trying to acquire resources, including on the distribution system at least cost. So can you just take a moment or two to explain better how the framework addresses these core investments versus applications with respect to that concept of least cost and reasonable cost?
Yeah, so for the most part, what we're looking at with the core investments is that those are foundational, necessary elements, and not unlike how we think about poles and wires, they are treated as sort of least cost best fit or lowest reasonable cost, whatever the actual term of art in a particular jurisdiction. But those are not usually done on a benefit cost analysis basis, because those are foundational and really enabling in many cases either achieving minimum reliability standards or perhaps policy objectives with respect to, say, in some states like distributed energy resource integration. And so the value, the benefit is actually from what the DER, what the policy, direction on DER integration that has essentially assessed what the value of DER is. In this case, the investment on the grid is the cost associated with that benefit that the policy has identified for DER. So it's in that context. Fritz will go into that a little bit more. Now, when we think about benefit cost analysis, those things like time-varying rates, what we would hope is that when we think about time-varying rates, there's going to be the benefit of the rate, but there's also going to be a cost to implement those components or those technologies that will, and in some cases, business processes, to be able to enable those time-varying rates and the benefit of those rates. So it's in that context we think about cost-benefit. And then customer self-supporting is where customers may specifically themselves on an individual basis have requested something, and therefore it only benefits them, and therefore they're paying for it, as opposed to all customers paying for one customer specific need. And there are examples of that already in practice in most jurisdictions I'm aware of.
Okay, and one more question that's really a follow-up, and just briefly, how does the framework address investments that are phased in over time when benefits may not show up unless and until other equipment and systems are installed?
Well, often, that's where really the strategic roadmap can come into play, where, hopefully in that roadmap, there's also conceptual cost benefit or cost effectiveness analysis in which you can lay out a multi-year investment and illustrate how the benefit accrues over time or aligns with policy objectives over time. Because in some cases, you're having to make an investment before, ahead of or slightly ahead of when you're going to implement. So, for example, you wouldn't implement time-varying rates before you had, for example, if you needed smart metering, you do the smart metering and then you implement the time of use rate. So you've got a timing mismatch, and so you need to be able to, that one's a little more clear because you can implement the rate almost immediately with the adoption of the meter. But in some cases, you may have a lag of a year or so between those investments and when the benefits start accruing.
Great, thanks, Paul. Back to you, Carrie.